Hello everyone, I am Jagdish Patel, Assistant Professor, Sandeep Foundation, Nasik. The name of subject is Broadband Communication System. This is Unit 3, Multi-Channel System, and this one is lecture number 1 in which we are going to see overview of WDM. I am having 12 years of teaching experience, specialization in digital communication. So first of all, we are going to see optical network and current uses. So video network conferencing, real-time medical imaging, scientific visualization, high-speed supercomputing. These are the uses of the optical network right now in the current scenario. Uses of optical fiber in networks. So first generation, second generation and third generation. These are the three different types of generations. In first generation, all copper networks contain a lot of noise, electron-electron interaction. Second generation, partially fiber or copper, better signal to noise ratio, a lot of optical electrical and optical electrical conversion. In third generation, all optical networks, the only conversion occur at the transmitter and the receiver, high bandwidth and little noise. So this is the difference between first generation, second generation and third generation of the optical fiber in networks. So transforming information, elements of an optical fiber. So these are the elements. Here the signal is sent over the optical fiber cable. The repeater receives the signal. After that it converts it to the electrons, amplifies it. After amplifying it, converting back into the light, and after that it retransmits the signal. So these were the process of transforming the information from one end to the another end using optical fiber network. Wavelength division multiplexing, WDM, partitions the optical bandwidth into a large number of channels, allows multiple data streams to be transferred along the same piece of fiber at same time. Consists of nodes interconnected by fiber optic links. Seems like we can module this with a graph theoretic approach. Basic technology, wavelength division multiplexing, WDM, of high speed TDM channels. Here we are considering n number of channels having different terminals which are applied to the mux. Mux used to take the multiple inputs and transmit it to the one output. After that the signal is transmitted over optical fiber cable, and after that in the receiver side there is the demux which used to convert that single signal coming on the optical channel to the number of outputs having n number of channel terminals. This signal or this particular output is called as WDM channels. Economical solution to reach multi-habitat capacity. Fiber optic transmission system to provide high capacity. Guided isolation for external interference. Very low attenuation of 0.3 dB per kilometer at the rate 1310 nanometer, 0.2 dB per kilometer at the rate 1550 nanometer, down to 0.16 dB per kilometer. Huge available bandwidth, high capacities, virtual 50T terahertz. In practice operates W45 terahertz bandwidth, all opticals drop fiber amplifiers. Fiber optic transmission system to provide high capacity. So this one is nothing but here the optical multiplexer is used as the input side. After that optical fiber section, optical amplifier to amplify the received signal. After that it is applied to the optical demultiplexer at the receiver side, and the receiver signal is transmitted to the end user. So this is nothing but the process of transmission of signal over the communication channel using wavelength division multiplexing. Typical bandwidth is 1529 to 1565 nanometer, 15 to 100 gigahertz channel spacing. Optical network in telecommunication everywhere. Keywords: capacity, distance, reconfigurability, green. So here, this is nothing but what? Optical network to support the continuous increase of multimedia traffic from submarine to terrestrial down to metro access network, from point to multi-point network. Here if you observe, there is a metro zone in from which we are connecting the different metro with the different metro zones with the help of optical network, right? The signal is here we are using WDM technology, right? After that, so that the signal can be accessed easily and it can be transmitted easily without any disturbances. Some problem associated with the fiber: two signals of same wavelength cannot travel down the same optical fiber in the same direction. Bandwidth is typically only around 30 to 40 optical wavelength. Current optical fiber can only hold 2 to 20 wavelength per fiber. A transmit receive cannot modulate a signal. Its wavelength cannot change. Network transformation. So long-term version of all packet transport from all IP services. Seamless migration towards all packet transport and OTN networking. Maintaining transport values for tight TCO control. Here the comparison between the past, today and coming scenario shows there is a greater extent of advantages by using optical fiber networks, and we can reduce the noise with the help of WDM technology so that the receiver can be received the signal with high quality. It's all about transport innovations, customer premises access, triple play, mobile backhaul, business network, industrial, public sector. After that, the microwave packets radios are transmitted with the help of optical fiber network with the different layers, and after that, the routers, after connecting to routers, it will be transmitted to the end user management system. So these were the basic introduction related to wavelength division multiplexing using optical fiber. Thank you.